Here we go. All right, so let me share my screen. So where we were discussing about the hardware. Okay, and today let's to continue the same topic. This is the part number 2 for the hardware overview. So when we just give a second, let me open. Okay, so let's discuss what hardware architecture we have in the Nexus devices. Okay, and what all the benefits we are getting from the fixed chassis and storage, the fixed chassis and the modular chassis. Okay, suppose we have this is a fixed device. Okay, when you have fixed devices, very first thing is you have what image type you have. Anyone who want to ask anything? All right. So very first thing is what type of OS we have. We have an XOS. And then on top of the NXOX, what is the underlay we have on the NXOS? We have two images on the NXOS. Okay, one is a kernel image, second is a system image. That overall builds the one image. We call that NXOS. NXOS having a two underlay images, and that underlay images we call that one image is your kernel image, which we call that kick start image. Okay, this is the image which handle your compatibility between your hardware and NXOS. Okay, it controls the drivers bit and compliant it drivers and make them compatible with the NXOS. So whatever hardware we have, okay, on top of the hardware, we have a first layer of image. We call that kickstart image, which is your kernel image. You can say that image is what is the kernel actually? Kernel is to maintain your hardware driver. Hardware driver, we also second name is a kernel images. Okay, when you have the hardware, if you want to install any images on top of the hardware, then you need a kernel. Your software must be compatible with all the features, with the hardwares, with the ports, everything. That's the reason Cisco first install the kernel images. Then second is feature image. We call that system image. This is also we call that feature image, where all the protocols you run on top of this image. So this before 5.x version, or rather till 7.x version, or you can say the old modules like Nexus 7000, Nexus 5000 devices, they had two images. So if you want to upgrade, downgrade, or install, uninstall anything on the Nexus hardware, you have to basically go install and install the two images. One very first image is kickstart image, second is the system image. If you do not have two images, they will not work properly. Okay. Then after the 7.x version, Cisco has released the one bundle. Okay. Cisco has released the version for the Nexus 9000. For Nexus 9000, we have bundle images. Okay, that bundle image, it means you have single image with the kickstart and system, both the features. Before Cisco, from Cisco portal, you have to download the two images to install in any devices. Now that image has been synced into the single image. So if I go here and see that Cisco software download, for example, okay, and look for the legacy devices, for example, Nexus. Okay, for Nexus, for example, I'm not sure whether they have 5,000 also available. Nexus 5,000, 5,500. Okay, here we have 5,500 devices, which are pretty much old. You will see that here we have a kickstart image, we have a system image. If you want to really download, so you have to first download the kickstart image. These are the kickstart image. They have separate image. They are the separate image. Same version you have to go and download for the system image. And both the image separately you have to upload in the box in order to upgrade the box, right? Now, if I go for the another hardware, which is the Nexus 9000 series, okay? And if I go for the Nexus 9000, for example, 92, 93, in any boxes here, what they have here, just system image. NXS, if I click on the firmware, this is the firmware which you can upload it, but this is for defect. And if I go for the system, this is the image. So you see here is standalone switch. There is a no system image, there is no kickstart image now. This image size has been increased to 2 Gbps. Before, the kickstart image was 100 Mbps and the system image was like 200 Mbps. Now they have, since the feature has, this image has been loaded with the multiple features extra, that's the reason these are the heavy image now. So from now, just make sure that when you have 9,000, you do not need a two images. However, when you have a legacy infrastructure, it's still if you have 7,000 some devices running in the infrastructure, you will not have one option, but you have to download and upgrade, downgrade whatever you're doing with the two images. And you have to activate two images at the same time. Okay. Now, if I go for the here, this is the main architecture of the OS and XOS. Okay. Just give me a second, guys. It's really. Okay, here we go. So if you see here, this is the underlay hardware. Okay. On the underlay hardware, we have a Linux kernel, which is a kickstart image. Then on top of it, you have a system infrastructure, which is system image. What is the role of the system image? It has all the layer 2, layer 3 features. That's where your feature will be enabled on the devices. By default, if you purchase any non-Nexus devices, they will have all the feature by default compatible. It means you can run any feature. But in Nexus devices, that is totally opposite. If you purchase Cataly switches, you can use that. You have to just configure the protocol. It will be automatically start working. But in Nexus devices, that is totally opposite. You do not have that kind of feature whatever we have in a Catalyst and on the other devices. The reason is because of the data center security. Okay, let's understand what NXOS advantage we are getting compared to the other iOS images. Okay. First of all, this is the unified data center operating system. This is only dedicated for data center solutions. None of the hardwares in the infrastructure are being dedicated for specific reasons. Okay. People use different image hardware for different purpose. That's because lack of I would say that cost, lack of experience, lack of architectural awareness. Third feature is this it has a many more feature compared to the iOS devices. There are certain feature which iOS devices never supports. Like for example, OTP feature it has a FabricPath, it has a BPC feature. So data center devices altogether had the unique feature which were not available to any other vendor. Okay. In the Nexus devices, these were the devices which has a only certain specific feature here. Okay. Fourth is the flexibility and scalability. As I said, if iOS devices was mainly to operate the access point and LAN cables. Okay, but here iOS devices has limitations. You cannot connect 400 gig inter devices or servers and expect them to have work with ultra low latency with the billion packet per second process, right? Here, these devices are designed for that purpose. They have a flexibility. They can operate with the layer 2 as a layer 2. They can operate as a layer 3. They can operate as a layer 4 devices also. It has virtualization support. So these devices support the multi-tenancy. When I say the multi-tenancy, if you aware of in the firewalls, we have a context, right? We call that in load balancer, we call that routed domain, right? Partitioning dividing the physical devices into the multiple virtual devices. This is what only Nexus devices supports. Other devices support the layer 2 layer 3 separation. Like we can create the layer 2 VLAN, we can create the VRF for layer 3 routing. However, if you want your one hardware to act as a separate four types of different hardware virtually, that's where your Nexus, these traditional Nexus were capable enough to support them. You can divide one hardware into the 4 5 virtual devices, and each devices you can operate as a individual devices. Okay, it has a resiliency to recover quickly. The reason is it can support the modular and the ss we call that uh, just give me a second. Yeah, it has a ISSU support, which was zero downtime upgrade. It means if you have infrastructure, there are very less hardware available in the industry even now who support the ISSU. ISSU means in-service software upgrade, which if you have more than one devices or two devices, you can upgrade the hardware without rebooting the hardware. Whenever you will reboot, either you perform that such a feature, you have to pay the extra amount to Cisco as a feature to support the ISSU, because not all the hardware support the ISSU. Basically, when you upgrade or downgrade, you have to reboot your boxes. But this Nexus devices has a feature which can support ISSU. Very few, even I think Catalyst 6500 has a ISSU upgrade feature, but you have to, as I said, you have to design, architect the ISSU based suggestion. Then you can achieve the ISSU upgrade and achieve that kind of a scenario in your infrastructure. But which we can utilize in the traditional devices. Okay. Now, since Nexus 9000 we have, ISSU has no relevance here because we have a leaf and spine architecture, which is a predefined architecture. Cisco does not give you to go for the individual upgrade or something like that, which we're going to discuss how uh, solutioning, especially the leaf and spine architecture, help you not just in terms of the traffic forwarding. It has a lot more advantage compared to the other architecture. Okay, data center initially was the first device which were compatible for dual stack, because the number of the components, number of the VLANs, number of the features were required. We had that kind of feature which was compatible to run dual stack on the hardware, because dual stack hardware are limited available even now. If you go to Cisco and say that I want to have the dual stacks, it means IPv4, IPv6 at the same time in my infrastructure. There are limited hardware which you can utilize for the dual stack. But in terms of the data center, you have you had that luxury features where you can utilize that feature at the same time. However, now in past 2 3 years, almost all the devices, I would say not all, but 90% of the devices are compatible with the dual stack. Okay, excuse me, guys. Dual stack. If you talk about the comprehensive security, it has a MACsec, it has a layer 2 BPD security, it has a layer 3 access list and many other features, which we were getting the in the it has a COPP, it means control plane protection, it has a data protection policy, lot of by default features, security features you get from the Nexus devices, which are not available now in the Catalyst devices. Okay. Now, if we talk about the hardware specification, so if I go for the generation 1 hardware first, okay, then move forward to the generation 2 hardware, we have a Gen 1 hardware. In generation 1 hardware, mainly we had 2 3 components. We had 5000, 4000 is not relevant. 5000 we had in 5000 family, we had multiple models. Okay, 5000 in the 5000 we have 5000, 5500, 5600. Okay, so if the moment I say that 5000, 9000, this is the address family. It means that is the hardware family. On the hardware family, we have a multiple devices: 5000, 10, 5000, 20, 5000, 30, 40. I think they are not they are no longer available. Here we have 5500, 5532, 5500, 48. What 5596? What are the difference between them? Basically, the difference is the capability. The 5000 devices were pure layer 2. These devices were layer 2, layer 3. Now the new generation, which I think currently now is also available, 5600. Okay, they are much more compatible, especially with the VXLAN concept. Even till generation 2 or 3 data center lab, they were providing the Nexus 5000, 5600 for the uh, exam. Okay, but these are the 5000 address family. They were totally dedicated for the connecting the your in host or in points, which are your you know which were your kind of uh, layer 3 boxes where we were keeping these devices. There was a specific role for these. Okay, we had when you have 3-tier architecture like this. Three-tier architecture, what devices we were keeping where? This is place for 5500 to 5600. Okay, because these devices were supporting layer 2, layer 3 feature both. Okay. However, initially we had these devices. What devices we can? This is the access layer. Okay, this is aggregation or distribution layer. Here you had separate devices which is your core layer. Okay, we usually deploy that routers and everything in the generation 1. This is generation 1 data center. Okay, don't get confused. You can configure even Nexus 5600 also as a core device also. Okay, but this is how we used to define 5000 we can deploy. We can deploy 5500. Why we do not suggest to deploy 5600 in the access layer? The reason is these devices are expensive, and if you deploy the access layer, you get to run only layer 2 features. Okay, when you have a layer 2 feature, you do not spend that kind of money to operate that capable hardware for the access layer. Okay. If you don't mind, could you please mute yourself, Hariom? Thank you. Just give me a second. All right, so these were the generation 1 hardware. If I take a look into the generation 1 hardware, here we go, 5000 series. Where are they? These were the platform. Look here. Okay, they they were the first generation of the hardware was pure copper. Okay, then in the 5000 second generation was your copper fiber, both option were available. Then 5600 was the latest generation which we have currently. Even now, some of the customer uses it. What was the feature? Look here, this 5000 has a limited port, limited features, limited fixed 24 wire port, limited bandwidth, everything was limited over here. Then this feature, this particular device 20 has a 50 fixed port, which was supporting 10 gig or 1 gig ports plus 2 4 expansion module. It means you can add on few more ports extra if you like to. Then come to the second generation of the 5000. They were more capable to handle the more 1 to 10 gig ports. They were also supporting the some expansion for the fiber channel ports for SAN connectivity. So basically data center devices initially Cisco from starting only they had a very clear vision to design as a dual purpose device. It means you can use this device for LAN also, you can use this device for the SAN also, storage area network. It means you do not need to spend a lot of money to sub for the SAN environment. When you have where you have iSCSI storage, where you have a JBoard, where you have a NetApp with the fiber channel connectivity, that's where you and the running that fiber channel, pure native fiber channel architecture. These devices were designed for the SAN and LAN both dual purpose. So Cisco, in data center point of view, Nexus devices were always were compatible for the dual purpose. Okay. First LAN SAN. Now we have in latest generation LAN SAN plus SDN, software defined networking. Cisco has added one more feature. Now Cisco is another feature has added called the Sonic OS. So same device, same hardware has a four purpose. You can use as a LAN layer 2. You can use as a layer 3. You can use as a SAN device also. Some, not all the hardware, some hardware. You can use that device for the ACI also for running the software defined networking SDN. You can run same device for the AI also, which is your Sonic OS. You do not need to install the NXOS, right? So from very beginning only, the Cisco has that clear vision. I will be providing the data center devices with the multi-purpose or the multi uses of these hardware. That's the reason you cannot compare these hardware with the Catalyst and any other devices. I hope it's clear why Catalyst and the Nexus devices have the difference. Okay. Just give me a second. These okay, so these are the this is generation 3. This is the Nexus 2000. They were designed to optimize the cost for the Nexus 5000 initially. Suppose if you have this hardware and you require 20 more ports, and you just require 20 more ports. You do not require this separate hardware. You simply say that you order the extra ports, and these are the extra port. We call that Nexus 2000 devices. This is the facts. They do not have any brain. They do not have anything. These are just a port extension, just a data plane.
Yeah. Okay, Bhargopal here. 1 minute.
Yeah.
See, in this Nexus 2K, right? If I see a snapshot you are sharing with us, right? These
Yeah.
ports are MPA ports, or it is just like can we remove that MPA, or it is just fixed? It is an MPA mode.
Okay.
Uh,
So these are the she's talking about the facts, right?
yeah, correct,
These are the
correct,
fix. These are the fix. These are the
fixed.
fix.
Okay, okay,
So
okay.
suppose NPI, if you want to have
Yes,
these were
exactly.
the devices. Okay.
Oh, okay, got it,
Okay. They
got
had
it,
a separate device. Suppose by default they were providing the 48 ports. Okay.
got it,
But
got
if you
it.
want to have a 20 more ports, you can have
Correct,
it. But if you
correct.
want to have, like, for example, 50 more ports or 48
Uh-huh.
more ports,
Okay.
And it not want, because these are the layer 2, layer 3 devices. These are
Got it.
expensive, right?
Got it.
So in half price of these devices, you can
Mhm.
purchase the FEX,
Okay.
fabric extension devices.
Extension devices. Okay.
Okay,
Got it. Got it.
which will be managed through the parent devices. They will
Uh-huh.
not have any separate brain. They do not have any routing table, MAC table,
Got
anything
it.
like that. They will
Got
be
it.
managed through the parent devices, which
Got
we're
it.
going to discuss.
Got it.
Okay.
Noted. Yeah. Yeah. Thanks. You
Okay.
can proceed.
Cool. Now, these were the generation one. I'm not spending too much time on them because no longer these devices are used in production. Okay. So don't worry about these devices. Just make sure that you should be aware of generation one data center hardware. Okay. Here we were connecting the storage. You were connecting the, all the devices. Here we were connecting the firewalls, load balancer, everything. Okay. Now, what about if I go to the hardware section and say that Cisco data center switches, and if I go for the 5000 series switches, okay, I should have, Cisco, you just keep lying on the portal. Cisco Nexus 5000. Here we go. Always, whenever you go for any solution, anything, always read the data sheet. That's the accurate information, no matter whoever is saying what. Always
Mhm.
read the data plane of the particular model. Okay, it will have all the major minor details. Look here, this is the 5600 devices. This
Mhm.
is the 5696 device, which has a huge ports, 1240 gig ports. They had around 300 ports.
Mhm.
So
Mhm.
these were devices which designed for the core layer. Okay, they had 310 gig ports in single devices,
Mhm.
and they were the hot swappable. You can customize these hardware, single hardware. Okay, where you were keeping here. Look here, this is the generation 2 hardware. Okay, generation 1 hardware has no 7000 devices. This is the generation 2 hardware, where you were keeping the, and in generation 2, Cisco has introduced 7000 devices. The 7000 devices we were using as a aggregation layer, or either we were using as a core layer devices. Okay, so these Nexus 7000 you might see in the infrastructure, some of the clients are still using 7700 series switches. These are the modular chassis. They were These devices are capable to carry the multi-terabyte traffic per seconds. Okay, these devices are in design. Usually, you will see that in service provider infrastructure. So, for example, IBM. So when I was working in Cisco in 2020, 2018, 18, I think 18, 19 something. I was part of the IBM Tech Refresh. So like IBM has IBM Cloud, right? They were using these devices as a edge device. It means if a client coming and going out to their infrastructure, they were onboarded these some of the cluster servers. So they were using the 7,000 devices, and even Catalyst 6500 devices in their infrastructure. So till 2023, many customers were using these 7,000 devices as a core device to manage their infrastructure, because these devices are more than enough uh, to handle the multi-terabyte traffic, and they are scalable, reliable, optimized, optimizable hardware. Okay. Now Cisco is replace these 7,000 devices with the Nexus 9000 devices, modular to modular, fixed to fixed. Cisco has given the option. Okay. Now, if I go for example, any specific model number, I will go for the 5600 end of life. So see here, for some of the hardware, I still might be end of life, end of sale. Look here. So 5500, 5600, and 6000 devices. These are the latest one. Okay. They or they have starts supporting the even OS operating system. Cisco is forcing customer to move to the new hardware. What hardware replacement they have given? They have given the new hardware replacement. I don't know why. Currently, if you say that new part replacement, we are currently saying that no replacement part. However, Cisco in the end of the day says that to replace this hardware with the Nexus 9000. Look here, these are the hardware. Look here. Specific model number they said, but you do not worry about the specific model number because they are suggesting a specific model number because how many ports you require 10 gig, 25 gig, 40 gig based on that Cisco recommended. You can have anything like any hardware based on whatever is your new requirement. Look here. They all has been replaced with the Nexus 9000. And these are the fixed chassis with the, if you go for the chassis, look here. These are the 96 port hardware, 9300. If I go for the 7000, for example, 7000 devices are being replaced with the some different devices. Nexus 7000, end of life. Basically, if you go for the 7000, it has 7700. They are still in use, some of the production, especially the 7700. 7000s are end of life, end of sale. However, 7700 series switches is still in use, and their last day is 2028, which is some of the customer you might see in Nepal or some small countries who cannot afford to refresh these hardwares very quickly. You will still see that these hardwares are still in use. They already have, they are not renewing the contract here. If you want to renew it, they this is the last day, and this is the hardware support itself is last day. And if you see here, this is a chassis is replaced with the chassis. Either you go with the 9500, 9800. So rather than study about these hardwares, 7000 too much, focus on these hardware because these are the hardwares which are the future, right, for us. Now, transition is very important. You should be also knowing that what are the capability of existing hardwares. Okay. So like I discussed here, a 5000 series switches family. Let's discuss the 4000, 700,000 series switches. Okay. Here we have a two family devices. Okay. How transition is going on. I forgot to mention here. Okay. So these devices now has been replaced with the what devices? We have a 9000 Nexus 9000 fixed modules. Okay. These devices, Nexus 5000 devices. Whether you go for the access layer, or 3-tier architecture, 2-tier architecture doesn't matter. Cisco says that you go ahead and replace these devices with the specific hardware. Okay. Now, if I go for the 7000 other module where we have a second generation of the hardware, Nexus 7000. These were the chassis. These were the chassis. It means you can customize these hardware based on your convenience, based on your requirement. And these are the hardware. Okay. Sorry. These were the hardware. Okay. Now, what are these hardwares? If you see that they require multi-rack units. Some of them are 7-feet devices, some of them are 5-feet devices. Okay. You can customize your hardware based on your requirement. If you see that 7000 devices, we had option slots. How many? This 9 has us 9 slots. 2 for the CPU engine and 7 for the data plane. 7 types of hardware, 7 types of interface slots you are getting. For 10, total 10 slots. For 18, we have 18 slots. Okay, and this was the 14 rack unit height, 21 rack unit, 25 rack unit. They were huge devices. I had 3D catalog, but unfortunately Cisco had discontinued that, which were very beautiful hardware. Just give me a second. Cisco 7000 series. Okay, they had basically 3, 4 gen hardware, 4 slot, 10 slot, and 9 slots. Sorry, 18 slots. These were the hardware. If we compare this, look here. Come on. Where is the 7th? Okay, 7000. Look here. How many devices we had? 4 slot device, 9 slot device, 10 slot device, 18 slot device. Okay, these were the devices we had for the
So this is
Nexus
generation
7000.
2, correct?
Yeah, generation 2. These
Okay.
devices are also end of life, end of sale. So you will not see in the infrastructure anywhere these devices are still used.
So generation 1 devices got the replacement with N9K, correct? That's what the previous
Yes,
slide.
exactly. Because they were so these were the generation 1. Okay.
Okay.
5000 also has been introduced in the generation 2, generation 3. Because if you see the module,
Mm-hmm.
5500, 5600, right?
Mm-hmm.
So in Gen 1, this is the series. In the series, we have a generation 1, generation 2, generation 3 devices also.
Got it.
Okay. Similarly, we have a in 7000 also. These are the generation 1 hardware. Okay. Gen 1 hardware, all of them. Now, this is the 7000. Now, Cisco has replaced, this is the generation 1, sorry, not generation 1,
Two.
yeah. Generation 2 hardware. Generation 2 hardware. Cisco said that I am going to have generation 2. What about the Gen 3 and Gen 4 hardware? I would not
Mm.
say Gen 4 hardware, but yeah, still some of them are still valid to the 28, right? So I will consider them as Gen 4 also. Okay. But they're not compatible enough. These are the 77,000 series switches. It's still chassis. Okay. Which were replaced, which were the replacement of the 7,000 devices. Okay. Replacement of the 7,000 devices. And what are those devices? These are the devices. Okay. Some of the devices are still valid 2028, till 2028. Okay. Like here. If I open any of the chassis, for example, if I open this chassis, uh, sorry, 2 slot, 6 slot. Okay, this is the 2 slot chassis. Okay, they have just fixed port number of the port. They have CPU and limited resources they have. Okay, and if I go here, how many ports it can support total, and what is the total capacity? What are the features it can support? You see here, Lisp it can support, MPLS it can support. Catalyst devices cannot support MPLS. Just to make sure that. Okay. But Nexus devices does support. VXLAN can support. VPLS cannot support by the Ethernet. Your Catalyst devices. eVPN cannot support with your devices before. Now in higher end, now it is available also. Okay, so we have a circuit-based ASICs. A lot of features we were getting on this hardware. Okay, now if you see the end of life, end of sale, there is no longer available. But what about the 6 chassis devices? This is the 6 chassis devices where you have module number 1, 2, 3, 4, 5, 6. Total 6 hardware, where you have 2 CPU, primary and secondary. You can customize whether you want to have primary, secondary, or you want to go with the one. How many ports you want, and each port can be, this can be the 40 gig ports, can be 10 gig ports, 25 gig ports, 1 gig ports. Okay, but make sure that this has a limitations. How many 10 gig ports you can have? 10 gig, how many? 192. 9640 gig you can have. 4800 gig you can have if you want to have this device. The total capacity of this hardware is can carry 21 terabyte of the traffic. Okay, what about the these 10 slot and 18 slots? This is the 10 slot hardware. Look here. And how many 10 gig, how many? This is the hardware. See here, this is the limitations. So as I said, depends, these hardware were replaced. This is the 18 model number. This is the huge. I never seen any customer using 18 hardware, but there is 7,000, 7,700. I've seen till 10, okay,
Okay.
in big infrastructure. So
Vijay,
there might be a customer who, like Google or any other big customer who were using these kind of devices, which I never interacted with. See here, 700 port 10 gig.
Vijay, one
Yeah.
clarification. Now, see, generally I see that, right, 10 GB, 40 GB, 100 GB ports. So I'm just trying to understand, do we have any option in data center to having a breakout port, for example?
Yes,
po-
we do
port-
have.
Okay, okay.
We do have breakout port options, but
Uh,
not all the hardware supports. Okay.
oh,
There
okay.
are, so especially the generation one, these devices, 5,000 devices, they had
Uh-huh,
like 40 gig ports, right? These
uh-huh,
hardwares,
uh-huh.
which where you can split into the four 10 gig ports, something like that, right? Even
Mm-hmm,
7,000 also, some of the hardware. If you
mm-hmm.
want to break out, then you have to purchase the breakout line card
License.
type. Suppose
Oh, uh-huh,
here we have these many line cards, right? Data plane.
uh-huh.
So if suppose one of the line cards, we want 10 or 20 ports should be breakout supporting. So you can purchase that hardware. Not all the hardware support the breakout because
Mm-hmm, mm-hmm,
that's not a cost effective solution in my view. Okay, that's a
mm-hmm,
jugaad which we do
mm-hmm.
in India. Okay, yes it is.
The reason which I asked,
What is a breakout port?
Breakout port means suppose you have 40 gig port, okay, and you have a four 10 gig servers, okay, but how many ports you require? Each server require one 10 gig ports, right? And you have 140 gig ports, so you can purchase one cable, and that is a 40 into divided by 4, which is a 10 gig 4 ports. You can split that single port into the 4 different ports. That is a breakout.
Okay. So
Okay.
it's not a hardware, it's a cable that is modified.
Yeah, but these hardware ports also should support a breakout, right? So it's a hardware also. When you have purchased any 32 port, suppose hardware, this one, or 5600. So there are certain ports in 5500 devices, certain ports reserved for 40 to 100 gig ports, right? But in your
Hmm.
infrastructure, you might not have a 100 gig port or a 40 gig ports, right? So
Right.
you might consume these 40 gig into the divided by 4, right? You have 4 servers, you want to utilize this 40 gig interface also. So that way you can purchase the breakout cable, and but also you have to have make sure that the device feature is supporting breakout. Okay, feature
Hmm.
breakout is also important. Not all the hardware support the feature breakout. Doesn't
Okay.
matter how many ports you have. If device, when you purchase the device, make sure that your devices must support the feature breakout, because that's advantage also for some cases.
I
Suppose if
thought
you have,
we
yeah.
use FX for this.
No, that is a that is a, again, for fix this extra design you have to do, extra effort you have to spend. Fix costs more than your breakout cables, right?
Okay.
So when you, I mean, in the other day, to be honest, in my view, I've seen that in the other day, it's all about the cost. Okay, customer care about the cost. They want to save some money for their pocket. So it doesn't matter how well architect you architect their infrastructure.
Okay.
You have to, as a consultant point of view, you have to also think about the architecture, right?
Can you show me the cable, how it looks like?
Yeah, sure.
This is the first time
Next
I
is
heard about this.
breakout cable configuration. No, breakout cable. Yeah. This is good, giving you the good look here. This is the fiber, but copper also breakout available. Fiber also. Look here.
Hmm.
You have a big 40 gig ports here, 40 to 100 gig, and divide by 4. Let me
Okay.
give you the more better picture if I have. And these are the configuration which you do, right? like this. Look here, this is the one. Okay, even this module, Nexus 9000, I think this module supports this breakout. So it's a advantage for the for you because if you're purchasing these hardwares, anyways, these breakout cables are damn expensive. It's not a cheap cable. So you might end up spending thousands of dollars for this kind of cables.
Okay.
Okay.
Thanks.
Now, if I go for this hardware, these hardwares are also, there are certain infrastructure which are running, but end of the day they have been replaced with the Nexus hardware. Okay, which are currently active. Nexus 9500, we call that chassis, 9800 chassis. How many do you have? So if I go for the 7700 hardware module, if you see that these are the end of life end of sale also. If I say here end of life, so it will give you suggestions which hardware you can go ahead with. Come on. Yeah, here we go. 9800, 9500. Look here. Rather, I will open Cisco Live documents where you have pretty good. So these were the, these are the, you can say that coding. If you have any hardware which is the E, it means 800 gig it will support. If you have D, it can support a 400 gig. C, 100 gig. L, 50 gig. These are the sign, okay, of SFP of the and as well as on the port. If I go for the Nexus 9000 series, see here 90, it started with the 9300, 9500, 9300, 9400 also available. Now Cisco is focusing on the 800 gig ports. So since 2019, Cisco is keep pushing towards the higher Ethernet bandwidth for the infrastructure. If I go for the 9800 series switches, these are the recent introduced switches in 2023-4, I think. They have introduced, which can support these many 400 gig slots. Because nowadays computes are requiring the major bandwidth for that. Okay, software on chip SoC is supported on all the hardware still. These hardwares are compatible to run the dual mode, ACI and non-ACI. If you see that these are the hardwares which they have, I will be explaining the architecture inside it. Okay, what is the meaning of each these components. Don't worry about it. But they have also line card which can have a better line rate, better fabric module, high availability. They have 9400. 9400 has different purpose. It can support the 25 terabyte of speed. It's huge. And they have 400 gig port, which can support the MACsec and CloudSec with extra features. Okay.
So
And if
both,
I see, yeah.
so both 7700, uh, if it is replaced by 9500 series switches, so both,
So there's a two things.
uh,
So initially, Cisco has introduced 9500.
okay,
Okay. Now, 9500 also Cisco said that end of life, some of the hardware is gone. Okay.
uh-huh,
They are introducing 9800, 9400. Okay.
mm-hmm,
9400 is still valid, but
mm-hmm,
they have already announced the end of life for this.
mm-hmm,
Okay. If I go here, say that Cisco Nexus 9800, 9500 end of life, you will
mm-hmm,
see that they have made the announcement. Look here. Some of the line cards, like this one. They have already made even Nexus 9000, they are retiring. Okay. It's not like they are keeping it for a long
mm-hmm,
time. Look here. If I go here, 9500. So line card wise they are retiring, but yeah, they are eventually targeting to have a 9800 because 9800 is very niche in the current scenario. So they eventually will, but yeah, they will take time. Okay, if you see the 9500,
Correct.
yeah,
So both can, so even 9500 uh, uh, can can be can be positioned in the as a core, right? As a core and spine, right? Or like only
yes,
okay,
you can use anything these
anything. Okay.
devices. Okay, but
Uh,
basically to using core will make more sense.
sense.
Okay,
Okay. Okay. Okay.
compared to the having these devices as access switches because they are damn expensive, right?
Okay.
9400, let's see, open it. Okay, how many series we have? In
Uh-huh.
9500, we have
Mm,
like three series. Okay, as a use as a spine, we I just suggest that as the use as a spine switches, but you can use anything. We have a 4 slot switches. Okay, we have a 8 slot switches. We have a 16 slot switches in 9500. Okay, if I go for the 9800, they have a limited options because these switches are designed to handle the AI and the ML based data center. Look here,
mm,
and they have VOQ because SOC was there, but SOC was not enough to
mm,
handle the AI ML data traffic because they were designed to uh, tackle the CPU based traffic, right? Since GPU based traffic is coming, they have enhanced the virtual output queuing for the specific AI ML fabric.
mm,
They have, look here, what is the capacity they have added? It's 50 plus, it's around 100 plus terabyte of the speed they
mm,
have added. They have two switches, 4 slot and 8 slot as of now. Okay.
mm,
Because, so I would not say it's replacement of the 9500. However,
mm,
you can say that people are moving towards the AI driven data center. Okay. So
mm,
they will eventually suggest to use these devices because they are capable to handle the 400 gig and 800 gig ports.
mm.
Okay. These ports they can support.
Okay.
Like they can support
Okay.
400, 800, 100, 25, 10.
Mm,
Breakout option is also available for this 100 into divide by 10,
mm,
right? So they are capable enough to handle it. If I go for the 9400, 9400, I don't know why they have designed, but same purpose. I would assume that because I've never used this with the new hardware. I think this is a smaller version of 9800. Okay, if you want to, but they have given the 9400 as a name, which can support the 400 gig ports, 200 gig ports, and 10 gig ports. In upcoming data center, you will not see any kind of 10 gig or 1 gig ports, to be honest, because the requirements are, going in another direction, right? Look here, this is the main feature for us in down the
mm,
line now. Okay,
mm,
extensive programmability should be REST API, should have a DME engine, data management engine, should have a CAF, application framework, should have a POP, should have a netconf, a YANG for DevOps configuration. These are the some extra features
mm,
which these devices supporting compared to the 7000 7700 devices. In
mm,
7700 devices, we had a limited options for REST API. Okay, they had no MACsec security. They
mm,
had no option to have a uh, AIML traffic. You see here AIML traffic. AIML is not about just AIML. These are certain protocols. We call the ROC, okay, which must be compatible with your infrastructure. Priority-based flow should become. You should have it. You should have explicit conjunction notification options. You should have a DCB option. You should have a ETS option, enhanced transmission, right? You should have a fair dropping option. So these option was not available. They are only compatible with the specific hardware. Okay, they should have a dynamic. So currently, what we do the manual QS, right?
correct.
But
Correct.
here we have a dynamic packet prioritization also features. It means based on the flow, based on the traffic and traffic options, they can dynamically prioritize the traffic, identify that this traffic need a more priority because of the a certain type of traffic, this traffic need the less priority because certain other
Yeah,
type of the traffic. Okay. It has
Oh,
ISSU upgrade also, which is a best feature I would say that they were missing in
helpful to see
two
you.
versions. Yeah, excuse me. Could you please mute yourself, Rahul? Okay. So as I said, these are the devices are designed for different type of beast. Okay. See here, million packets they require for longest prefix match, shortest prefix match. They were supporting only 250,000
okay.
packet. Now they have crossed the million. Okay. Okay. So for this they cost a lot, but yeah, this is how we are moving towards.
Yeah, one clarification.
Mm-hmm.
This switch on chip or system on chip, SoC, right? I'm
Uh-huh.
just trying to understand what difference it is bringing into the what additional feature or advantage we are getting when we say switch on chip or system on chip is supported. Like just trying to understand from the
Yeah, just give me a
legacy.
second. Let me give you architecture. Okay.
Sure.
I have perfect, fine. I've got this. So when you design the leaf and spine architecture,
Mm-hmm.
okay,
Mm-hmm.
SOC. Just give me a second. I will give you the architecture view, how the architecture looks like for the SOC and what are the role of them. So when you have a leaf and spine architecture like this, okay,
Mm-hmm.
we have, for example, notaries, not this, and not this, not this. Where is architecture? When you have ingress and egress architecture,
Mm-hmm.
that's where you have a two chips.
Mm-hmm.
Okay,
Are you
and
saying
that
about the pipeline architecture, like
no. ASIC architecture I was
oh,
looking for.
uh-huh.
Okay. Like if we have, this is the traditional, not really, don't want this. Okay, SOC
Mm-hmm.
architecture with the Nexus 9000. Okay, I will rely on the Cisco hardware, not other.
Mm-hmm.
It's the same one which I was opening. I see that something somewhere. Because I explain, I teach that
Mm-hmm.
as
Mm-hmm.
architecture view, okay, internal.
Okay.
So
Okay.
don't worry about it.
Okay. Sure.
I need to find out I
Sure.
must have saved somewhere.
Yeah. Yeah. We'll take it up when it comes. No problem.
Yeah, yeah. So I will be the next will be the only the explaining the SOC only. Okay,
Got it. Got it.
I will be explaining that how the SOC should work and what things make difference like this architecture, right?
Mm-hmm.
This is very important to understand
Mm-hmm.
to how the traffic flow is working. That's fine whether we are going for the any X module, Y module
Got,
doesn't really matter, right?
got it. Got it.
Right, just give me a second.
Yeah.
I must have saved somewhere. The problem is when you have too many documents, it's very hard to find out what you have kept
Got it.
where.
Got it.
Right, this is not. I do not really. I usually was prepared. I used to prepare
Mm-hmm.
the hardware documents. The problem is now Cisco is releasing every week something new, so it's
Yeah.
very hard to cop up. So it's better to rely on Cisco official sites. What
Got
exactly
it.
is going on, right? Yeah, and this is the one. I think this is the document. Or what? I think so. Yeah, I think this is the document where I was looking for. Control F. Yes, it is.
Mm-hmm.
You've raised your hand.
Yes.
Yeah, Billy.
So the other thing is what you say, the context separation, like
Mm.
if you want SD-WAN, that also depends on how modular the switch is, or do we have that feature in fixed module switches also?
Oh, I didn't get that SD-WAN integration.
Uh,
Could you please
you
elaborate
said
more on this?
you said the context can be for four
Oh,
ports or six.
virtualization.
Yeah,
Virtualization
yes.
on the hardware. So basically, virtualization, it supports, um, like in firewall, we have a context, right?
Mm-hmm.
In Nexus second generation, we had a call the we call that as a VDCs, virtual device context. But
Mm-hmm.
that is available. That was available only on the specific hardware on Nexus 7000, 7700. Now we have multi-tenancy, right? In a
Okay.
is sort of a defined, right? Where you can Cisco. So previously, what is the hard firewall limitations, virtualization limitation? You can divide just 3-4 time, right?
Mm-hmm. Right.
Depends on the license and module. So, but in the similarly, we had a same kind of issue with the Nexus 7000 also. We were able to optimize only 3, 4, or 8 time maximum. Now Cisco come up with the idea saying that I'm going to club hundreds of devices and I will virtualize them 1,000 time or 3,000 time. We call that multi-tenancy. It means 3,000 separate type of context you can create in the Nexus 9000.
Okay.
Okay, that's what I was saying, that virtualization has been enhanced into the here. So if we here, I don't know why this architecture is not giving the proper view, but if we see this architecture, and if we next, yeah, this architecture, right? This architecture. So currently this is the mainly focus on the ACI. Okay. Uh, I think the NFE represent the forwarding engine standalone SOC only. I believe I need to read this document properly. But if I go here and explain you where SOC will be sitting, this is the tech label documents.
So
Non-Mary's
the
architecture
switch
document.
architecture.
Anyways, I will be explaining in separate class. Okay, let's
Sure.
not waste too much time on this.
Sure.
I have somewhere in the
Got it.
documents
Got it.
where you when ports having directly traffic, they will be decided by the that particular ASIC whether they are the SDN traffic or they are the non-SDN traffic. Okay, based on traffic enter into the infrastructure. I think now you have given me the task to. I need to find my document. Man. Anyways, that's fine. I have somewhere. Okay. So if I talk about these hardwares, especially the Nexus, just give me a second. I might have not really. Architecture-wise, I should have somewhere. Not this one. $9,300 architecture. Oh, this is not the what I was looking for. Anyways, so if I go for the 90,000 devices, 9,000 devices, okay, as I said, we have 9,800, 9,400, depends on the features. We have a 4 slot, we have 8 slot, we have 16 slot, we have a 2 slot switches, a combination of these switches. Okay, and these switches, so here these were supporting the VOQ SOC. Okay, that is the ASIC device. ASIC. If I talk about these devices, they were also supporting a VOQ SOC plus VOQ. I will explain where it is supporting VOQ and here. Here, these devices supports the SOC plus ALE ACI leaf engine, ASE ACI spine engine, and ACI leaf spine engine. These are the ASIC type, and I think new devices which are supporting Sonic, I need to check that what level of ASIC they support, because these SOC and ACI ASIC cannot support these Sonic hardware, Sonic architecture. So make sure that I need to check here what ASIC device, ASIC vendor they are using for the Sonic. Okay. Because some of the hardwares are designed for this support, this kind of supports. Okay. So I'm stopping here today. The next topic I'm going to cover is the architecture of the leaf and spine and their internal hardware architecture. Okay. So far we have discussed hardware modules, brief. I'm going to go, I will not just discuss this Nexus 5000. I might discuss 1 or 2 minutes. 7000. I will focus on the 9000 series switches alongside with the 7700 series switches, where I'm going to discuss the hardware architecture. Okay. How they work, so what all the
A quick
internal
question.
architecture. Yeah. Yeah,
So
Gautam?
in this CCNP, do we cover SDA
No,
by any
no.
chance?
This is the
No,
data
right?
center.
Okay.
So for SDA, you need to attend the enterprise.
Okay, enterprise. Okay.
Yeah. But that's enterprise syllabus. If you have any doubt or troubleshooting something, I can discuss that, because I have worked on SDA, but the curriculum point of view, no. This is a pure data center class.
Okay, okay.
Okay. All right, then I will be stopping here. Okay. And we'll see you next class with the hardware architecture class.
Sure. Thank you.
All right. Thank you. Cheers.